Hello, this is Eric Larson reporting to you from Silicon Valley, California. I'm here to talk about a SolidWorks gear machine. I was given an assignment to design and build a small machine that uses gears and is compatible with Lego blocks. This machine was to be designed using SolidWorks and created using an inexpensive 3D printer. This video shows the steps I followed. It is intended to help a person who is new to SolidWorks understand all the keystrokes and steps. Okay, here is I'm intending to show an image of the machine. If I double click on it, should open. Okay, here it is, and we'll try to minimize some of this other stuff so that it's not cluttering up our background. Okay. In any case, here is the machine. As you can see, it's not real big. If you twist this knob, the gears rotate, causes this turntable to spin around. You can apply any Lego compliant thing to the turntable, and when you turn it'll rotate. You can also apply the base to a Lego compliant structure, such as what you have here. And okay, so what we see is if we go into SolidWorks and open up our SolidWorks design, you can see the SolidWorks design of the actual machine. And if we open an exploded view, we can see it kind of blown apart here. This is the base. You can see the Lego female pieces allow for attachment to a Lego structure. Here's the turntable. If you rotate this knob, it turns the shaft. The gears are coupled. And if you zoom, rotate the view a little bit, you can kind of see. It's pretty obvious how it all fits together. So if we hit escape, the other thing which we can do with this is we have a motion study. Let me collapse this back down to normal. We have a motion study which, if we run it, you can see that all of the gears actually rotate, and all the parts that are connected are rotating in synchronization with the gears. You can see here's the knob rotating, the turntable is rotating, gears and shafts. If you look underneath, you can see these pins that hold the shafts. They're also rotating. So that's pretty sharp. And what we're going to show in this video are the steps for how to do it. So if we minimize this and go back to our presentation and look at the second slide, we will see the steps that we're going to follow through in the process of this video. First thing is we'll create a two-dimensional drawing to constrain the gears to a plane. Then we will add the 3D gear parts. We'll show the gears meshing and rotating in an animation. Then we'll set up for 3D printing of our parts using Cura. Then we'll add some additional elements to the design, such as the base plate and the knobs and shafts and things. And we can create an animation of the complete machine in action. Okay. Some of the steps that we do, I'm not going to spend a whole lot of time on, because it's expected that the viewer understands how to do relatively simple parts creation in SolidWorks. Okay, the steps that we're going to do are broken kind of into 3 chapters. The first one is using SolidWorks to create the gears, then using Cura to slice up the model, and then we'll create our motion study of the complete machine. Okay, so the first thing that we want to do is, once we are in SolidWorks, we can close this one because we already have it. Okay, the first thing that we do once we enter SolidWorks is go to Tools, Add-ins. and verify that the SolidWorks Motion and SolidWorks Toolbox library are both enabled. You have to click both checkboxes on the left side and the right side. But we've got them. We see that it's correct. We can cancel out of this. Okay. So we will do File, and we will do New. We'll create a new assembly, and we'll just simply cancel out of this. We'll determine where we put it once it's started. Okay, the first thing is to make sure that we are using millimeters rather than inches. Okay, we know that we will draw on the top plane. We will create a sketch. Okay, the first thing that we want in our sketch is a line across the screen. It's already horizontal. We will make it into a construction line. We want an infinite length. Okay, our line is good. The next thing that we want to do is create 3 circles. 1, 2, and 3. Okay, that's cool. Escape. We'll dimension them. The circles will have dimensions of 72, 40 millimeters, and the small one will be 34. Okay, we're happy with dimensioning. Okay, then we will create some relations. The first relation is between our construction line and the origin. It's coincident. Okay, we're happy with that. Okay, then we will select the center point of the large circle. We will add a relation, and the relation is one of coincidence. This will put the center point on the line. Okay, in this case, we will select the midpoint of the next circle. We will, okay, and then we will, okay. Are we good here or not? Okay. Okay, point and line. And something's cattywampus here. I'm gonna start over. Okay, we'll select the point, and we will add relation. We've got the point and the line. It's coincident. Okay, we're happy with that. Okay, same process again. Select the point, add relation, and the line. Okay, coincident. Happy with that. Okay, so what we can do now is select the large circle, use our control key, multi-selection. We've got the 2 arcs, the 2 circles selected. We will say that they are tangent, and that's exactly what we want. Now if we select the medium circle and our small circle, all right, well, we better clear the selections. All right, we'll select the medium circle. And if we hit Control, there we go. And we say tangent. Okay. Now we have our drawing. It's exactly what we want. So I'm going to say exit the sketch, and I'm going to save it at this point because I don't want to lose what I've done if it's okay, GearVideo. Okay, and we're going to call this 3 gears. Okay, and it will be a SolidWorks file. Okay, we've got our drawing in place. The next thing that we're ready for is the actual gears. So we go to our design library, go up to the toolbox. We can navigate down to ANSI metric, go to power transmission, select gears, and the first thing that we want is a single spur gear. We'll drag it into our drawing. All set. Now this will automatically open a dialog box that will allow us to edit our gears. We just kind of by coincidence, this is exactly what we want. We want a module of 2, and that comes with a diameter of 72 and 36 teeth. So 72 divided by 36 gives us our module, which is 2. We'll take a pressure angle of 20, face width of 10, and we don't want a keyway. So we'll say that gear is just the way we want it. If we right click, or if we click on our drawing, we can add our next 2 gears in very simply. Okay. If we then select our middle gear, right click, and edit the toolbox, we know that this gear will have 20 teeth. So we will scroll up with our mouse wheel, select 20. All the other parameters are unchanged. We'll say that's good. We select our small gear, right click, edit the toolbox. This gear will have 17 teeth. Okay, there's 17 teeth. We're happy with that. Now the next thing we have to do is to select our large gear, right click, and say float. Okay, this will allow us to move our gears kind of into position, and we can position our gears to where we want them. Now this process always seems kind of awkward to me. There must be something about this process that I'm missing. We select the first gear, and there we go. Okay, now we can move it. We select the second gear. We can move it. We can select our small gear and drag it over to where we want it. Okay. Good. Okay. So now if we do a right click and rotate our view slightly, we can now see the bores of the gears. And if we hit escape to get out of selection, we can see that the gears are looking pretty good. So what we're going to do now is save our work just so we don't lose it. And rebuild it and save it. Okay, and then we're going to take a pause and jump to the next video, just so that it doesn't get to be too long. Okay, hitting pause.